Today we're going to be talking about absolute value inequalities. They're very similar to compound inequalities. Let's look at these two examples. We get the absolute value of x is greater than or equal to 4. I want to think about some integers that will make this true. If I plug 4 in for x, is this a true statement? Is the absolute value of 4 greater than or equal to 4? It's equal to it. So yes, this is a true statement. What are some other values? Well, 5 would work. 6 would work, right? 7, 8, 9, and 10. Also, the stuff in between 4 and 5 will work. The stuff in between 6 and 7. So basically, everything to the right of positive 4, if you plug these values in for x, it would make that a true statement. Are there any negative values that would work? Well, let's try negative 4. If I substitute negative 4 in for x, is this statement true or false? It's true. So negative 4 is the solution. Negative 5 would work. Negative 6, and so forth. So basically what we have here is everything to the left of negative 4. Now, looking at this graph that I have here, does this remind you of anything? Hopefully, it reminds you of compound inequalities containing the word or. This reminds me of an or compound inequality. Let's look at the bottom example. Let's think about some values that will make the absolute value of x is less than or equal to 4. Well, both 4 and negative 4 would work. What about 3? Is the absolute value of 3 less than or equal to 4? It is. What about negative 3? It is. So basically what we have going on here is all these values. All the values between 4 and negative 4 would make this statement true. Does this remind you of anything? Hopefully, this reminds you of compound inequalities joined by the word and. This little concept that we discovered here is the key concept to today's lesson. So here's the key concept. I would write this down in your notes. We got these two statements. The first statement says, if absolute value of ax plus b is greater than c, this also works for greater than or equal to. So if it's greater than or equal to, then this is true. Ax plus b is greater than c, or ax plus b is less than negative c. This is like absolute value equation. So remember, when you have an absolute value equation, you write it out as two equations. And then on the second equation, you change this side to its opposite. Down here, if you have less than or equal to, if you got your absolute value and it's less than or equal to, then you write it out as two inequalities joined by the word and. Okay? Now, how I remember whether it's or and is this word goal. Because remember, your goal, hopefully, is to get the answer correct. This little word goal only works if you have the absolute value on the right side. I meant on the left side. So I'm going to teach you a trick. This trick only works if the absolute value is on the left side, and it's all by itself. There's nothing on the outside of the absolute value. Well, the G in goal stands for greater than. And the O stands for or. The A stands for and the L stands for less than. So basically, If you have absolute value is greater than, well, these two letters in the word goal is G and O. That means you're going to use or. If you have absolute value is less than, well, less than starts with an L, you're going to use the word and starts with an A. This is a way to remember this. All right, let's look at two examples here. This is what you're going to be doing on today's assignment. It says solve and graph the solution set. All right, so we're going to start it off, we want to make sure my absolute value is by itself on the left side, and it is. And remember, our goal is to get the correct answer. That's our goal. So our first step is we're going to remove the absolute value symbols. I'm just going to get rid of them. And then I'm going to keep my inequality symbol facing the same direction. And then I'm going to write a second inequality. So I still got rid of my absolute value symbols. But this time, the 13, I got to change it to its opposite. So I can make this negative 13. So basically, that's like multiplying by a negative. So what we also have to do is flip this symbol here. So now it's not greater than, it becomes less than or equal to. We multiply that other side by a negative 1 to make it negative 13. Now we got to decide, is it the word or and joining these? Well, it's absolute value, right? Greater than starts with a G. What's next to the G? An O. So we're going to use or. So now this is just review. It's just like what you've been working on. So what you want to do is just solve each of these. So let's add 5 to both sides, add 5 to both sides. We get 6y is greater than or equal to 18. Divide by 6, divide by 6. Y is greater than or equal to 3. Or add 5. We get 6y is less than or equal to negative 8. Divide by 6. So we get y is less than or equal to, well, negative 8 over 6 is the same as negative 4/3. So that's negative 1 1/3. So this is our answer. Now we want to graph it. So remember, when you're graphing the or ones, you got to draw one graph that has all the solutions to your first statement, and then another graph that has all the solutions. So you can have one graph that has all the solutions to both of these statements. So let's do this first one in green. Y is greater than or equal to 3 will be a closed dot at 3, shaded to the right. Okay? Let's do the other one in red. That would be y less than or equal to negative 1/3 would be a closed dot at negative 1/3, shaded to the left. So you want to draw one graph that has all the red and green solutions. So basically, how the or ones work is that this is just going to be the graph. So here's your final graph. My final graph would be the graph that has all of these solutions and all of these solutions. So there's my final graph. Most of the or ones will be going in opposite directions. All right, let's do one last example here. It says solve and graph the solution set. All right, so again, first step is always make sure your absolute value is by itself and it's on the left side. It is. So now I'm going to rewrite it as two inequalities. So it's 5x plus 2 less than 17. And then I want to go 5x plus 2 and change that 17 to negative 17. And again, since I'm changing it to negative 17, I got to flip my inequality symbol. So it's not less than this time, now it's greater than. And again, I also need to decide, is it the word or and? So we got this word goal. It's absolute value, all right, my absolute value is less than starts with an L. What's next to the L and A? So this is an and one. So let's solve these two equations of inequalities. So subtract 2, we get 5x is less than 15. Divide by 5, we get x is less than 3. And let's go over here and solve this one. Minus 2, 5x is greater than negative 19. Divide by 5. So we get x is greater than or equal to negative 3 and 4/5. Here's our solution. Now let's graph them. So let's graph this one in green. X is less than 3. Would be an open dot at 3, shaded to the left. Let's do the other one in blue. X is greater than negative 3 and 4/5 would be an open dot at negative 3 and 4/5 and shaded to the right. Now what's joining these two compound inequalities? The word and. So we gotta find the solutions that make the green one and the blue one true at the same time. So that would be on your graph where the blue and the green overlaps. So my solution, my final graph, this right here is like a helping graph. It's not your final answer, so don't leave your answer like that. The final graph would be all the solutions between negative 3 and 4/5 and 3, shaded in the middle. So there's your final solution for that absolute value inequality above.